In this experiment, my main objective was to investigate Faraday's law of induction and to understand how the induced EMF in a secondary coil depends on both the applied AC voltage and the number of turns of the coil. To do this, I used two pre-wound laboratory coil and an E-shaped metal core, an AC voltage source, and an oscilloscope. The coil had a width of 2.5 centimeters and a top width of 3.5 centimeters, and I mounted them into a center of the leg of E-core. The top metal piece was then placed to close the magnetic circuit as much as possible. I used one coil as a primary and the other as the secondary. The primary coil was driven with AC voltage of 4, 6, 8 and 10 volts. The secondary coil output was connected to the oscilloscope with an 150 ohm resistor placed in the output to reduce the noise. To each input voltage, I measured an RMS voltage induced in the secondary coil. I repeated for the several coil combinations, such as 200 to 400, 400 to 800, 400 to 200, 400 to 400 for observe the errors, 400 to 800, 800 to 200, and 800 to 400. The results show the clear linear relationship between the input voltage and the induced EMF for all coil pairs. As predicted by Faraday's law, coil pairs with a large number of secondary turns produced higher output voltages. For example, the 200 to 800 was the highest and 800 to 200 was the lowest values. This matches the expected turn ratios and confirms the theoretical behavior of this experiment. I applied linear fits to epsilon to V graphs for each coil pair. The slope increased with the secondary turn number as it expected because of Faraday's law, and the R-square values are ranged from 0.97 and 0.999, approximately 1. This indicates that the relationship is strongly linear. It's a linear curve, and meaning the system follows Faraday's law quite well. And the experimental results are fits with the theoretical background. However, I also observed some errors in that experiment because one of the lowest error is 6% and the highest one is 23%, depending on the coil combinations. Overall, this experiment successfully demonstrated with the fundamental principles of electromagnetic induction. The induced EMF increased with both input voltage and the secondary turn count. It was predicted by Faraday's law, and also it is true. It has been observed that it is true with my experiment. Although the real world imperfections are done, such as maybe gross errors and also that type of errors which are measurable errors, general trend errors, such and such. However, this experiment also highlights the practical limitations of the transform systems and how sensitive magnetic circuits are. The main reason of the errors is the air gaps and the material type of loses. So that my experiment is like that.